An industrial psychologist wishes to study the effects of motivation on sales in a particular firm. Of 12 new salespersons being trained, 6 are to be paid at an hourly rate and 6 on a commission basis. The 12 individuals were randomly assigned to the 2 groups. The following data represent the sales volume in thousands of dollars achieved during the first month on the job. So here 12 people are selected and they are divided into 6 groups, and a measurement on their sales volume are recorded. Therefore, the test variable is sales volume. And we say grouping variable is type. Let's say type. One type is hourly rate and another type is commission basis. Type variable is in nominal variable with 2 values. One is commission, another is hourly rate. Test variable is sales volume. Measurement is in thousands of dollars, therefore ratio level measurement. We call these 2 groups of data 2 independent samples because they come from the division of a set of subjects. Okay. Test a hypothesis at the 0.1 level, alpha 0.1, that the population variances sigma squares for both groups are equal. So equals are HO. So you write sigma squares are equal. The first one is commission basis. Let's write C, and another one is hourly basis, hourly rates. Let's write H. So HO equal HA not equal. Now you get HA. And for this test, you must think of what table to use. The table to use is F. If you use F, always plus. The critical value is never minus. And alpha is 0.1 for 2 tails. Our table is the right tail, 1 tail table. Therefore, you must take only on the right side alpha 0.05. Our table is for 0.05. Degrees of freedom for numerator is n1 minus 1. n1 is the sample which gives us the larger variance. We don't know which is larger. N1 is commission or hourly rate, but in this problem, N1 and N2 and N1 all the same. Yeah, 1, 2, 3, 4, 5, 6. Each sample has 6 variables, 6 data. So N1 and N2 or N2 and N1 the same 6. So degrees of freedom for numerator is 6 minus 1, 5. For denominator is also 6 minus 1, 5. Column 5, row 5. Yeah. You have to read the critical value at column 5, row 5 in F table. Degrees of freedom for denominator, row number. Degrees of freedom for numerator, column number. Column 5, row 5. We see 5.05. The 5.05. The rejection region is on the right of 5.05. The critical value is 5.05. The critical value is positive 5.05. The rejection region is on the right of 5.05. If the value of test statistic is on the right of 5.05 greater than 5.05, we have to reject HO. Otherwise, don't reject HO. Now, let's compute the value of that statistic. We have to use formula 15. F is equal to S1 square over S2 square. S1 square is the larger value. Always the larger value must be put in S1 square. We have to find two variances, and at the same time we should record two sample means also for the next test. The next test is comparing mean values, average, mean, mu, says follow x, mean of x. Mean of x for commercial sample and hourly rate sample. Therefore, we will use calculator and look for x bar and s. We will record x bar and s for both samples. We have to set calculator in ST mode. ST mode. After that, we have to enter the first 5 commission data, the first 6 commission data, 22 to 28. After that, we have to press X bar and record, and then S or X sigma n minus 1 and record. Some calculators write S for sample variance, sample standard deviation, okay? And some calculators write print X sigma n minus 1 for sample as standard deviation. We have to use sample variance, therefore we will press S, after that immediately square equal to. Then we will copy the value and we should take 4 decimals. Move to ST, 22, enter, 25, enter, 27, enter, 28, enter, 24, enter, 28, enter. After that, shift to S3 square variance. Copy 4 decimals, 5.8667. SC square is 5.8667. Shift to H bar 1 equal to 25.6667. Copy it. AC bar is 25.6667. Reset mode. Move to 25, enter, 24, enter, 22, enter, 20, enter, 22, enter, 24, enter. Shift to S square equal to 3.3667. SH square is equal to 3.3667. Shift 2. 1 is equal to 22.8333. H pi is equal to 22.8333. By formula 15, we have to divide 5.86667 by 3.3667. The test statistic is 1.73. If we take 3 decimals, that is enough, because the critical value has 2 or 3 only. 1.743. Now the test statistic is not in the rejection region because it is not greater than the critical value. Therefore, we cannot reject HO. That means we must decide that HO is true, HA is false. So how should we write? The null hypothesis is not rejected, and the population variances for both groups are equal.